Welcome! Today we're diving into one of chemistry's most fundamental ideas, the mole. Not the animal, the number. And it's huge. The mole is the key that lets us connect the invisible world of atoms to the real world we can measure. Chemistry is about how atoms and molecules combine to make everything around us, but atoms are so tiny we can't see or weigh them directly. So how do chemists work with them? The answer is the mole, a special counting unit for the atomic world. This video is your guide to mastering this powerful concept. We'll break it down with simple examples, show why it matters, and teach you how to use it for real chemistry calculations. By the end, you'll see why the mole is a chemist's best friend. It translates atoms into grams and liters, things we can actually use. Ready? Grab your goggles. Let's explore the heart of chemistry. Let's go. Science rules. So, what is a mole? Think of it like a dozen, but way bigger. A dozen means 12. A mole means 6.022 x to 1023, Avogadro's number. It's just a counting unit for an enormous number of things. 1 mole of carbon atoms is 6.022 x 1023 carbon atoms. 1 mole of water molecules? Same number. Why this number? It perfectly links the atomic mass unit, used for atoms, to the gram, used in the lab. For example, a carbon-12 atom has a mass of 12 atomic mass units. A mole of carbon-12 atoms has a mass of 12 grams. That's the magic. The mass of 1 mole in grams equals the atomic or molecular mass in AMU. The mole isn't a substance. It's a quantity, just like a dozen. We use Avogadro's number to count atoms, molecules, ions, and more. It's the foundation of chemistry, letting us scale up from the invisible to the tangible. Simple idea, huge impact. The mole is the chemist's bridge between the atomic world and the lab bench. That's why it matters. Why bother with the mole? Because it bridges the microscopic world of atoms and the macroscopic world we can measure. Chemistry happens at the atomic level, but we work with grams and liters. The mole lets us scale up chemical recipes from atoms to amounts we can actually weigh. For example, 2 moles of hydrogen react with 1 mole of oxygen to make water. Now we're talking grams, not invisible molecules. The mole allows us to count atoms by weighing them. Without it, chemistry would be stuck in theory. We couldn't make medicines, fuels, or even clean a pool with precision. Stoichiometry, the math of chemical reactions, is built on the mole. It's the essential tool for real-world chemistry. That's why every chemist needs it. The mole concept evolved over centuries. John Dalton's atomic theory started it all, showing matter is made of atoms with different masses. Amedeo Avogadro proposed that equal volumes of gases contain equal numbers of molecules, a breakthrough, though ignored for decades. Wilhelm Ostwald coined mole around 1900, defining it as the molecular weight in grams. Jean Perrin's experiments confirmed Avogadro's ideas, and by 1971, the mole became an official SI unit. The mole's value, 6.022 x 1023, was set by counting atoms in 12 grams of carbon-12. Science builds on itself, step by step. The mole is a product of that journey. The mole's most important job is connecting the number of particles to their mass. Enter molar mass, the mass in grams of 1 mole of a substance. For elements, it's the atomic mass from the periodic table, but in grams per mole. For compounds, add up the molar masses of all atoms in the formula. Example, water, H2O, has 2 hydrogens, 1.01 g per mole each, and 1 oxygen, 16.00 g per mole, totaling 18.02 g per mole. So 1 mole of water weighs 18.02 grams. Need half a mole? Just weigh out 9.01 grams. Molar mass is your conversion factor between mass and moles. With a periodic table and a scale, you can measure out precise numbers of atoms or molecules. That's how real chemistry gets done. To master the mole, you need 3 key formulas. First, moles equal sign mass, G. Molar mass, G mole. Rearranged, mass equal sign moles, X molar mass. Second, number of particles equal sign moles, X 6.022 x 1023. Or moles equal sign number of particles, 6.022 x 1023. Third, for gases at STP, 0 degrees Celsius, 1 atm. Volume, L, equal sign moles, X 22.4 L mole. These formulas let you convert between mass, moles, particles, and gas volume. They're the shortcuts for almost every chemistry calculation. With these, you can solve problems, plan reactions, and understand chemical equations. They're simple, powerful, and essential. Learn them, and you'll unlock the world of chemistry. Practice makes perfect. Let's see them in action. Let's try some problems. First, how many moles in 54 grams of water? Moles equals sign mass, molar mass. Water's molar mass is 18.02 g per mole, so 54, 18.023 moles. Second, how many atoms in 2 moles of iron? Number of atoms equals sign moles x, Avogadro's number. 2 x 6.022 x 1023 equals sign 1.2044 x 1024 atoms. See? Just pick the right formula, plug in the numbers, and you're done. These calculations let you turn grams into moles, and moles into actual numbers of atoms or molecules. Every time you do this, you're using the mole to connect the lab bench to the atomic world. It's a powerful skill. Practice these steps, and you'll get faster and more confident. The mole makes chemistry calculations possible. With a periodic table and these formulas, you can solve almost any basic chemistry problem. That's the power of the mole in action. Keep practicing. You've got this. What? We've explored the mole, a chemist's counting unit, Avogadro's number, and the bridge between atoms and grams. The mole's history is a story of scientific discovery, from Dalton to Avogadro to Ostwald. Its real power is in connecting mass to number of particles, using molar mass. With 3 key formulas, you can convert between mass, moles, particles, and gas volume. The mole is the language of chemistry, essential for understanding reactions, stoichiometry, and more. Mastering it now will make every chemistry topic easier. Let's recap. The mole equals sign 6.022 x 1023 particles. Molar mass links grams to moles. The formulas are your toolkit. Now it's your turn to practice. Homework. What's the molar mass of H2SO4? How many moles in 100 G CaSO3? How many molecules in 0.25 moles CO2? What's the volume of 3 moles of neon gas at STP? Good luck. Keep practicing, and you'll master the mole. Chemistry is all about making the invisible visible. See you next time.